Hello, ladies, gentlemen, and in between, and welcome back to another episode of Maths with Hamblin with your beautiful host, Hamblin. And today, my boys, we're going to continue from what we did last time with graphing cubics. I'm going to go through two problems involving graphing cubics in increasing order of difficulty. So let's get into it, my boys. Okay, right, so let's get into this first problem then. We've got this lovely cubic polynomial here, f of x equals 2x cubed minus 3x squared minus 2x plus 3. And our first part is to show x plus 1 is a factor, and then our second part is to graph y equals f of x. Okay, so let's think about the end game here. If we want to graph y equals f of x, we're going to need to solve f of x equals 0 completely, right, to get all the points of intersection. So after we show x plus 1 is a factor, we're going to have to use polynomial division to get the quadratic factor and then solve for all the roots. So let's just get into it, shall we? Right, so to show x plus 1 is a factor, by the factor theorem, if we plug in -1 to f and that outputs 0, then we know that x plus 1 must be a factor. Right, so if we chuck in f of -1, that equals 2 times -1 cubed, minus 3 times -1 squared, minus 2 times -1, and then plus 3. Okay, -1 cubed is -1, so that's minus 2. -1 squared is 1, so that's minus 3. Then that's plus 2 plus 3, which obviously equals 0. So that's brilliant. So we've done the first part there. So then we can conclude by the factor theorem that x plus 1 must be a factor of f of x. Right, and so the next step we need to do to get all the roots of our polynomial so we can actually graph it is we need to do polynomial division so we can get the two factors, and then we can basically solve for all the roots. So let's do that. So remembering our method for polynomial division, let's write down our cubic, write down our factor, and then we need to put minus and then some number here, that when you expand this out it cancels with your first term here, and in this case that's minus 2x squared. Oh, I hope you can see that, but yes, that's minus 2x squared, which if you expand this out, you'll get minus 2x cubed, which will cancel with this, and then you also get the minus 2x squared, which will kind of just carry on for the ride. So this will cancel with that, and then we're left over with a minus 2x squared, which I'm going to add here. Okay, then we write down our factor again, and then we repeat the process. We think, what thing do we have to put in front of here to cancel with this minus 5x squared, and it's positive 5x, because if we expand this out, we'll get plus 5x squared, which will cancel with this, and then we'll get a plus 5x, which will add to this, and we get 3x plus 3. And then all we have to do now is figure out what coefficient here will cancel with this 3x, and it's going to be minus 3. But then look what happens when we have minus 3. It becomes minus 3x minus 3, which will actually cancel this all down to be 0. Which means we've done polynomial division correctly, and we've figured out what our quadratic factor will be. And remembering the method, the quadratic factor is all of these coefficients we chose here, but you flip the sign. So our quadratic factor will be 2x squared minus 5x plus 3. And then so if we just write f of x as the product of its two factors, then we get f of x equals x plus 1, and then times this other quadratic factor we found, sorry. Boom, so there we go. We've factorized f of x, and I'm going to go rub this out, and I'll see you after the next cut. Okay, so now we've factorized f of x as a linear factor and a quadratic factor, we're ready to start graphing it and answering part B. So the first thing to do when graphing your cubic polynomial is identify which type of cubic it is, much like you identify what type of quadratic you're dealing with when you graph quadratics. And in this case, you can tell by the sign of the coefficient of your x cubed term. And up here it's positive, meaning we're going to get a cubic that looks kind of like comes up from down here, swoop, swoop, does the hump, and then comes back up again. Okay, so now we know the general shape of our cubic. It's time to find the actual details where it intersects the axes. Now, of course, the easiest one is the y-intercept. This is where you have x equals 0, that's where the y-intercept will be. So all we need to do is find the y-intercept, is plug in x equals 0 to our function, see what value it spits out, and then we can plot that point as the y-intercept. Okay, so let's do that. If we plug in 0, well, I'm actually going to use this one up here because it's a bit easier. Then we'll just get, this will die, this will die, this will die, and we'll just get plus 3. And they'll all die because you're multiplying by 0. So the y-intercept is 3, which I'll label there. 3. Right, so now we need to solve the x-intercepts, where where the curve intersects the x-axis, sorry, that's where you got your x values, which output is 0 because the y coordinate is 0. So in order to find those x values, we need to just solve the equation f of x equals to 0 to find out which inputs x outputs a value of 0. And if we do that, well, let's just set the bot f of x equal to 0. Rightio, and now we've got a product of two factors equals 0. That should ring a bell. We need to set each one equal to 0 and see what x values pop out. This one's really easy. This is just x equals minus 1. Now this one, if we want this to be equal to 0, we're going to have to solve a quadratic. Effort, am I right? So now let's try and solve 2x squared minus 5x plus 3 equals 0, and I'm going to use my personal factorizing method, which I go through in a previous video, so if you don't know it, go watch that. Anyway, so we've got 2x squared, and so we can set up 2x and x, because 2x times x is 2x squared. Now when you think times our mystery numbers equals, and we want the sum of these equals to be negative 5x, and we want these two mystery numbers to multiply to 3. Okay, so let's start thinking about this. Okay, actually, this is quite easy, right? Because if we had negative 1 here, and negative 3, ooh, that is not 3, sorry. Then negative 1 and negative 3 do in fact multiply to positive 3, and negative 2x plus negative 3x sums to minus 5x. So we've found our factors. All you do is cross, like here, to find which values these different x's pair up with, and then we can get this factorized quadratic as 2x minus 3 times x minus 1. And if we set that equal to 0, I'm going to give myself some space here. Then we just think, okay, this one equals 0 or this one equals 0. So that's going to be, you're going to get, if you do some mental maths, you're going to get x equals 3/2. And this one you're going to get x equals 1. Smashing. So we've got all the information we need to start graphing our cubic. Let's do it. So it intersects the axes at minus 1, 3/2, which is actually a bit bigger than 1, and 1. Okay, and now we just draw our cubic, knowing the general shape of it. So we start down the bottom, we launch up, take a hump, we make the hump and make sure it crosses the y-intercept, then it goes back down, then it shoots back up again. Boom. What a beautiful cubic graph. Absolutely smashing. Right, let's go on to the next one. Okay, so my boys, this next one's going to be quite a hard one. It's probably the hardest one you'll get based on graphing cubics. I actually ripped it straight from a past paper, so that's cool. Anyway, so it goes g of x, nice function called g, equals x minus 3 times a minus x, and squared. So this factor is squared, and we're told a is between 0 and 3, and we're expected to graph this. I mean, how are we going to graph this if we don't know a, and we don't really have any way to figure out what a is? But don't worry. If we put, because we've given this information, a is between 0 and 3, we can actually plot a on our diagram. We just can't put it exactly where it is, and that's fine. And you'll see what I mean when we finish. Anyway, so first of order of business is to figure out what type of cubic it is, whether it's a positive or negative coefficient cubic. So, I mean, at first glance, it may look like a negative coefficient, right? Because if you do out the factorization, you might, if you miss the squared here, you might get x times negative x, and you think, oh, negative x squared, but to see clearly, actually, what the actual shape of the cubic will be, I'm going to rewrite a minus x squared as a minus x times a minus x, because you know that's what squared means. So g of x now can be written as the product of 3 factors. That's fun. Right, and now let's use that trick I told you last time, where you think about, if I expanded this, if I actually did the expansion here, what cubic term will I end up with? What x cubed term will I end up with? And you can think, well, the only way I'm going to get an x cubed term is if I do x times minus x times minus x, right? If you actually think about that, you're going to get minus x times minus x, which is positive x squared, and then times 1x, which is going to just leave you with positive 1x cubed, right? So what we've actually deduced here is that it's a positive coefficient x cubed graph. So it's actually going to start from here, go whoa. Now that was hard to see at first glance, but we've done it, so that's good. And now what we've got to do is find now the axes intercepts. Now the first one's easy, the y-intercept. Just plug in 0. we get 0, then we get minus 3 times a squared, so that's going to be minus 3a squared. Righty-o. And now we need to find the x-intercepts, which is when this function equals 0, so we just need to solve g of x equals 0, which is pretty easy in this case because we've got it as the product of 3 factors. So from this one, we'll get x equals 3. From this one, we're going to get x equals a, but we're also going to get x equals a from this one. So actually, this is a cubic that only has 2 solutions, and that's something you might come across in your travels, in your mathematical travels, a cubic with only 2 solutions, and that's actually what's called a repeated root, because you've got 2 factors that are the same. Anyway, so our cubic graph is only going to intersect the axes twice. Well, how are we going to do that? And I'll show you how. We're actually going to have to end up making the cubic tangent to one of the axes, and I'll show you how that works. Anyway, so if we plot 3 and a on our diagram, well, okay, 3 is probably here, let's just say, but we know a is between 0 and 3, so it's somewhere in this region, but it actually doesn't matter where it is. So let's just plot a anywhere we like. Cool, that's fine, it's within the region, we're fine. And now we need to figure out how to draw the cubic where it only crosses the axes, well, the x-axis twice at least. Okay, so let's try and figure this out. So it's going to come up like here, going to pass through a, sorry, that did not pass through it, that's fine. Then it's going to come back, but then the only way we're going to make it cross the x-axis only twice is if we just have it just touch there and then come back up. So there we go. We've actually graphed our cubic perfectly there, and that's how you do that. That was quite a hard question, mainly because of the a minus x squared, which can trick you, and also just the fact you've got an unknown, which you're trying to graph, and also the fact you've only got 2 roots for your cubic, so you've got to figure out how to make it only intersect the x-axis twice. Anyway, that was fun, that was difficult, and that is the end of this video as well. I hope that was helpful, my boys. Please consider subscribing to Maths with Hamblin, and see you in the next one.